Now we're going to talk about trig functions at any angle. We'll begin by looking at the signs of trig functions in different quadrants. So let's say we have our circle, and here on the circle we have our x and y axis. Now let's say we have a point right here, P, and this point P has some coordinate x, y, and if this point P has the associated angle theta right there, we can sort of extend this down to our circle, and we have this right triangle. On this triangle, we would have some x value and the y value as our two bases of the triangle, and the triangle doesn't have to be a unit circle now, it could be a circle of radius r. Now, since we're in quadrant 2, we know that in quadrant 2, our values for x are going to be negative, and the value for y is positive. So we're going in a negative direction for x, but positive for y. Now, recall that sine is y over r, and if our y is positive, and our r, well, r is also going to be positive, okay, because of the radius is a positive value. And so we have a positive divided by a positive, and so a positive over positive gives us another positive. So we know that sine of theta is going to be positive in the second quadrant. Similarly, with cosine, we know that cosine is x over r. And we have that our x is negative and r is also going to be positive. So we have a negative over a positive, which gives us a negative. So cosine is going to be negative in this quadrant. And finally, we have that tangent of theta is y over x, which is a positive. X was negative, and so positive over negative is negative. So tangent is negative in quadrant 2. And then, very similar, we get that cosecant of theta, r over y, still positive number over positive number, which is positive. Now for this one, we can just really say cosecant is 1 over sine, so 1 over a positive is still positive. And likewise, we get that secant of theta is either 1 over cosine or r over x, but it's going to be the same sign as cosine, and so we have secant is going to be negative, and then cotangent of theta is also a negative. So this leads us to the following table, and if we have the quadrants, and then we have our column for positive functions and negative functions. In quadrant 1, all 6 trig functions are positive, and none of them are negative. X, y, and r are all positive. Now in quadrant 2, we just saw that sine and cosecant are positive, and then all the others, cosine, secant, tangent, and cotangent, are negative. In quadrant 3, what we can do is, doing the same way that we showed in quadrant 2, we would find that tangent is positive and cotangent is positive. So in quadrant 3, remember that x is negative and y is negative. And so since tangent is y over x, it's a negative over a negative. So in the negative functions, we would get sine is negative, cosecant is negative, cosine is negative, and secant is negative. And then finally in quadrant 4, in 4, x is positive and y is negative to get to quadrant 4. And so we have cosine and secant would be positive, and then the other functions, sine, cosecant, tangent, and cotangent are all going to be negative functions. So if we had an example, let's say that sine of theta is going to be negative and cosine of theta is positive, what quadrant does theta lie in? Now, sine is negative, and so we look when sine is negative, and we have that sine is negative in these two quadrants. So it's either going to be in quadrant 3 or 4, just from this first piece of information that sine is negative. So now we know we're in quadrant 3 or 4, but if cosine is positive, quadrant 3, cosine is not positive, cosine is negative, and in quadrant 4, cosine is positive. So it's quadrant 4 where cosine is positive and sine is negative. So here we have our answer, quadrant 4. Now we can draw these quadrants out and look at the positive and negative based off of the trig function. So for sine and cosecant, we know that they are positive in quadrants 1 and 2 and negative in 3 and 4. For tangent of theta and cotangent of theta, we know they are positive in quadrants 1 and 3, and negative in 2 and 4. And then finally, for cosine of theta and secant of theta, we have that they are positive in quadrants 1 and 4, and then negative in quadrants 2 and 3. So putting this all together, we can write in quadrant 1, they are all positive. Quadrant 2, sine is the one that's positive. In quadrant 3, tangent is positive. And in quadrant 4, cosine is positive. Now, when sine's positive, we also know that cosecant is positive, and tangent's positive. We know that cotangent is positive, and then when cosine's positive, secant's also positive. Now, a mnemonic device for remembering this, we have two of them. So the first one says, a smart trig class. So where we have the capital letter A, S, T, and C, and they correspond to going around our quadrants in order. Quadrant 1 is A, all. Quadrant 2, smart for sine, 3, trig for tangent, and C, class for cosine. And then the other mnemonic device is all students take calculus. And again, this is A for all, students, sine, take for tangent, and then calculus for cosine. Now let's do an example. Suppose we have that sine of theta is negative 12 over 13, and that cosine of theta is negative 5 over 13. Compute the exact values of the remaining trig functions. Now, remember, we have that quadrant 1, they're all positive. Quadrant 2, we're doing all students take calculus. Sine is positive. Quadrant 3, take for tangent, and then quadrant 4, calculus for cosine. So we have now, looking at our information, sine of theta is negative. So we're going to be in the negative quadrant for sine, which means that if sine is negative, it's going to be in one of these two quadrants. Sine's positive in 2, and for all of them. Additionally, we have cosine is negative. Since cosine's positive in all, and here, cosine would be negative in quadrants 2 and 3. Therefore, the only quadrant where they both are negative is quadrant 3. And so now I'm going to go ahead and just draw a triangle like this. You can draw the triangle if you prefer how it would look like in quadrant 3, but I'm just going to draw a triangle like this because I'm used to triangles looking like that. All right, so if this is theta, we have that sine of theta is negative 12 over 13. So sine is opposite over hypotenuse, and we have that. Or we could have used the second information that cosine was adjacent over hypotenuse. I'm going to ignore the negatives right now because we know what values they take on. And so the next thing we can do is we have sine and cosine. Tangent of theta is opposite over adjacent. 12 over 5. And we know since we're in quadrant 3, tangent is positive. So tangent of theta is 12 over 5. The remaining trig functions is going to be cosecant of theta. And cosecant of theta is hypotenuse over opposite, 13 over 12, but cosecant is negative in quadrant 3. Cosecant is only positive where sine's positive, and that's quadrants 1 and 2. Secant of theta is adjacent, which is 5 over, or hypotenuse over adjacent, 13 over 5. And again, just like cosine is negative, secant is negative. And then finally, cotangent is going to be 5 over 12, because it's adjacent over opposite, and we're in quadrant 3, and tangent and cotangent are positive in quadrant 3. Now we could have done these using identities, where tangent was sine over cosine. Cosecant would have been 1 over sine of theta. So we could have used those as well, instead of looking at opposite, adjacent, and hypotenuse.